hosting a COBOL Friday and seeing so many familiar faces and a few new ones. I have a fun poll going to for you to be able to tell us where in the world you are from. It reminded me of the continent song that I've learned over the years, singing to my toddlers. But um, today here we are to talk about CICS, and we have someone with years of experience from training to doing a lot of webinars and instruction around CICS. And so I'm going to give it up to Ezriel. Ezriel, we're eager to hear from you, and thank you so much for spending your Friday morning with us here on COBOL Fridays.
Thank you, Sudarsana. So I was going to say good morning, but of course, after that poll, I realized it could be morning, noon, or afternoon. So from wherever you are, good morning, afternoon, or evening. My name is Ezriel Gross. I'm a Principal Solutions Advisor at Rocket Software, and here today to talk to you about CICS interaction. So what I have planned for today is to talk about what is CICS and who uses it. So I'm not making any assumptions that you know what it is. And then I jump into some technical things like pseudo-conversational programming, CICS application services, some supply transactions, talk about some of the development tools that are available as well. And then CICS connectivity, how various different regions can be connected, and then a little bit about some of the advanced stuff in CICS as well. So CICS as a product has been around since 1969, right? So that's when CICS was originally developed. So it's about 51 years old. And one of the best quotes I found on the internet, and you can see it yourself, is according to IBM, every second there are approximately 6,900 tweets, 30,000 Facebook likes, 60,000 Google searches, yet CICS processes more than 1.1 million transactions per second, which is over 100 billion per day. So CICS has been around for quite some time, and it's still very heavily used. So there are some stats on the right-hand side over here. I can't tell you how many of these are still accurate because it depends over time when I've added or removed them. But certain things I can point out, and that is there's a huge percentage of IBM mainframes that still run CICS. It runs almost 100 billion transactions a day. There's many programmers that know CICS, although less and less, which is why we're here. And there's at least 200 billion lines of COBOL. The replacement costs are probably more than $20 trillion today if you include inflation, even with people getting off CICS. So there's the main menu when you sign on to CICS. Some environments still use this as a good morning message. That's what it kind of looks like. But what is CICS? So CICS is an online transaction processing system. It's simply middleware between the operating system and the business applications that you write. It allows you to manage the user interface, retrieve data and modify it, and handles the communication. Now, you have to realize that CICS was invented so long ago that writing applications that interface directly with the operating system were a lot more complicated. So if you were writing batch programs back then, you had to know a lot more about the environment. So CICS back then as middleware made it easier to code applications in one sense, but I'm going to show you, you had to learn a little bit more about how to program in a CICS environment. So this is just kind of a list of the customers that use CICS today. It's still plenty of banks to do mortgages and account reconciliations, payroll. They'll verify whether or not you have a credit, all kinds of stuff. Brokerage houses still use it for stock trading or clearing, some human resources functions like payroll, and then insurance companies as well will use it for policy administration, or it'll be the database of record, for example, for all claims processing. So still plenty of large customers use CICS. And then I jump right into this, and people always wonder, why do I start talking about batch versus online programs? Well, the easiest way to understand what CICS provides is to understand what we had at the time CICS came out. So if you go back to those old days where we couldn't even afford a PC on our desk, not like we have today, it's sitting on our phones, most of the data processing was batch oriented, right? So the data came in sequentially. It was a file of requests. It was all processed. And once the results were there, it was all transmitted at once. But over time, as the hardware became cheaper, we had this need to be able to process individual requests randomly, immediately, so users can actually do things like check their bank balance, stuff like that. So with the need of online processing came a different style of programming, as I'm going to show you. Now, response times tend to be sub-second, and it's used for things like application credit card authorization, right? So if you go into a store and you buy something, and you swipe your card and they're doing an authorization, chances are pretty good on the back end it's running through a CICS system. So the requirements that came out were it's applications that need access to large amounts of data. They have to be able to look through that data, process it accurately and very, very quickly. We have to be able to handle individual sets of users or large environments. So, for example, it could be a single region in a single LPAR, and it could go across multiple LPARs within a sysplex. So a huge number of users, simultaneous access to data, and again, large amounts of data. Now, the requirements are intense security, reliability, and data integrity. As you could imagine, I think you'd get really upset if you woke up one day and your bank account was emptied, right? Although that could happen for other reasons. But nonetheless, we had to make sure that it was reliable and secure, right? Now, one of the other requirements, and again, I don't know if it's a requirement or just something that happens, is each user has the perception of being the sole user of the system. So if you've ever worked in a CICS system, you know, you type in a transaction, you hit enter, get a response back, you get an immediate response. So the set of changes have to be guaranteed to be logically consistent. What that's basically telling you is, you know, if you remove money from one account and you put it in another account, that has to either all happen or all not happen. So we have to have that integrity. So to understand terminology in the world of CICS, we have to understand the terminology in the rest of the world and how it relates to CICS. So we all know we can have a business transaction, which is just a sequence of related events. So an example would be retrieving an account balance, right? In the world of CICS, we use a 4-character TRAN ID to represent an application that we want to run, simply because when CICS was designed, it used 4-character TRAN IDs. So a transaction can also perform a set of operations. This is just an example where you type in a 4-character TRAN ID, you get a screen back, you fill in some data, you get the results back, right? And so that is a business transaction. In the world of CICS, we talk in this term of tasks, right? A task is a logical unit of work, and multiple tasks can actually make up a physical transaction, right? So CICS, we're going to see, breaks this up into individual tasks. The individual tasks can run multiple programs, as we're going to see. So a task is just an instance of a transaction entered by a user. Usually it begins when they type in a 4-character TRAN ID, hit enter, get a response back, you've run a task, right? A task. So a task can run concurrently, right? And that's why multiple users can run the same thing at the same time. CICS does this multitasking under the covers. Programs are generally loaded once and shared by all the users that may need the same program, and that's how we were able to get a smaller footprint. And then each task runs, getting a brief amount of CPU until they issue something that holds them up or the task physically ends. So the first thing I pop into here is conversational versus pseudo-conversational programming. Conversational programming is easy to understand. It's almost like a batch job. It starts, it runs from beginning to end, and at the end, it's done. Pseudo-conversational programming is what we showed you just a minute ago in tasks, where you actually want to complete an individual task, but you haven't done the entire business transaction. So what you're really doing is terminating at the end of a task and thereby avoiding system overhead. I think a picture will actually show it better. So here's a picture of it, and you can see on the left-hand side, I have one transaction that's one task, and you can see that what you could do is type in a tran ID, hit enter, get a screen back, but instead of returning control back to the system, you issue a wait. Now, if you issue this wait, then the system is waiting for you to propagate a response and hit enter again. And if you decide to go to lunch or take a 15-minute break, the system is hanging, holding a set of resources and waiting for you to respond back to it. Now, CICS, like any other system, would have a limit to how many of these things it can actually support, right? And so if you wrote your applications in this manner, you would be conversational, and effectively it would look like one big batch job. Pseudo-conversational programming is a different methodology. And what it does is when you type in that transaction and you send a response to the user, you do an exec CICS return, which is basically telling the system you're finished. Now, if you went to lunch, nobody is running. Yeah, you might still be looking at a screen, so you can't tell the difference between this or this unless you were the programmer, right? But you would be looking at a screen. There's nobody waiting for a response to come back to you. Now, should you come back with a response, type in some data and hit enter, the application has to restart, figure out where it left off within the application program, process some data, and do it again. So this same function, which is a single task, would have to be broken up in this example into 4 individual tasks. But the big advantage is we would get much more multitasking, right? More multiprocessing, and that's how most people run and design applications in the world of CICS. Well, that means that the programming is going to look a lot different than conversational programming. But before we get there, let's talk about application development. In terms of application development, like most other environments, we split it up into 3 different categories: presentation services, business logic, and data services. Now, presentation services today are generally handled by some other server or perhaps some client process or your mobile phone, right? So even though CICS can do the presentation services, whether it be 3270 green screen based or HTML, JavaScript, JSON, we can do it all, but generally it's done on other platforms. Where we excel is in the business logic. That's what's written in COBOL, PL1 assembler, Java today, right? And then the data services, where we actually get the data from, is usually separated out into a separate layer, a separate set of programs, although some people combine these 2 layers together. Okay. So I'm going to get into the world of CICS. Any questions come up so far? Okay, so in terms of an overview, let me start by talking about application services. So this is middleware. And again, if you go back to many, many years ago, what we were trying to do is make interacting with the operating system much easier. So IBM invented this exec CICS command or API structure, exec standing for execute, right? And effectively, they provided commands to make some mundane functions easier to do, like reading a record from a VSAM file. If you do it in a batch job, you have to set up file descriptors, as you guys know, in a COBOL program. You have to set up special JCL as to where the file comes from, right? But effectively, you have to do a bunch of extra work. You're going to see in the world of CICS, all you do is add exec CICS read to your application, and life goes on. Now, obviously, somebody else has to do some work, but it's not usually at the programming level. Now, many languages are supported. We're going to talk COBOL, but it could be a lot of other languages. And then there are these built-in transactions. CEDF and CEDX allow for stopping before and after every CICS command executed within your program, so you could do debugging. There's even some debugging tools for your COBOL programs themselves. CECI is the command interpreter, allows you to execute commands in CICS without writing any programs or testing a command before you add it to your program. And there are a few others as well. So What does a COBOL program look like when it runs in a CICS environment? Well, it looks like a COBOL program, but the only difference is it's sprinkled with these exec CICS commands. So effectively what you're seeing is a standard COBOL program, but when you need the services of CICS, you sprinkle it with an exec CICS command. Now, what does an exec CICS command look like? Well, in COBOL, it says exec CICS. We give it a function. I gave you an example, read, and then options and arguments. So if I'm reading a file and it's a key sequence data set in vSAM, what do I have to do? I have to specify a record ID, which would be the option, right? Record ID being the key. And then parentheses, I'd have to give it the actual key that I want to read, right? And then in COBOL, we use an end exec as a terminator for this command, right? So the CICS programs simply look like batch programs with exec CICS commands in them, right? And those are used to request services from the CICS environment. So here's a little sample CICS program, right? This is a very simple program. So I spent all this time talking about, conversational versus pseudo-conversational, and I never mentioned non-conversational. Non-conversational is a program that only has one function, and therefore it is a transaction and a task in itself, right? So this doesn't have any follow-through. We don't have to worry about state information, but it's a simple program to understand. So in the world of COBOL, you can see I have a working storage section, right? There's my input message. I'm going to type in a tran ID followed by a part number. It's going to do a read of that part number from a vSAM file and output it to the screen. Very simple stuff. There's not a lot of COBOL in here. So in the procedure division, you can see an exec CICS receive command. You can see a read into command, and then you could see and evaluate the response. If it's a normal response, I'm going to send a message out to the user and do a return. That's the end of my program. If it's a not found, I'm going to do a different return, and I'm going to end my program. If I make a mistake or something goes wrong, I'm going to issue an append, right? Because I expect this not to happen, right? So let's take us into the world of development and see how I would do this. So I'm going to switch over here, and by now I'm probably disconnected from TSO. No, I'm not. Look how lucky I am. So I'm going to go into option 3.4. So I'm going to first show it to you this way. And I have a bunch of libraries, right? And you can see I have a COBOL library right here. And in the COBOL library, you can see I have a member called part program. Now, part program looks pretty much like what I showed you earlier, right? I might have fixed a few lines that I had some bugs in or something like that, but otherwise, it's pretty much the same as you saw earlier. Now, to run this program, I'm going to walk into a CICS environment, right? And so this is a terminal owning region, and I'll explain multi-region environments a little bit later on. And if I type in part 00001, you can see it says location warehouse 6, life is good. So how would the development process actually work? So let's make a change. I'm going to change location over here, and I'm just going to put in an X for the heck of it, right? And I'm going to save this off. I'm going to hit PF3 and go into my JCL. And you're going to see there's two types of compiles, right? In the current world, we have something called an integrated compiler. COBOL is now integrated with CICS, so you can actually do the translation of the CICS command and the compile at the same time. But to show it as an example, I can do a separate step called translation. So I'm going to submit this job. Now, as you know, when you submit a job, you could split your screen, you can go into SDSF, and you can take a look at the job that ran. If you have the right prefix, it won't show you every job in the system. So there's my job at the bottom. And you probably know I could put a question mark next to it. Look at the JES message log, and you could see I got all condition codes of 0, and I have 4 steps because I mentioned I would be using a separate translation step. Now, what I'm going to show you is just the step after translation, because one of the things I want to show you is exec CICS commands are not valid COBOL. So what happens is the translator comments out the CICS commands, puts in a bunch of move instructions followed by a call instruction, right? And that's what it replaces the command with so that it's valid COBOL. Now, he mentions these EIB fields, and I will mention at the top of the program, he also inserts certain things into your program. He builds you a linkage section where he sticks something called the EIB at the top, the exec interface block at the top of the linkage section. And then the next thing in the linkage section is a COM area, even though we're not going to use it right now. And then he has procedure division using EIB and COM area. Now, I've done all this. I'm going to show it to you in a bunch of screens in just a second. But first, what I'm going to do is I'm going to start another session because unfortunately, or fortunately, my application actually runs in 2 different regions. So what I'm going to do now is I'm going to log on to 2 different regions, because just because you compile a program in CICS doesn't mean CICS picks it up. Since CICS has already preloaded the program, there's a master terminal command, CEMT, that you can issue, CEMT inquire program, and you have to know the name. And you could inquire on it, and you can issue an N for new copy, and you have to new copy the program for the changes to take effect, and I'm in this region over here. Because my program runs into 2 different regions, I'm going to do the same thing on the other region. If I could spell. And what I'm going to do here is new copy it here as well. And remember what I did. All I did was change location to have a typo so that you believe me that I'm actually doing development. So now that I've new copied it, I've brought in a new version of my program to CICS. If I type in part 00001, you'll notice it has location with an X. So that is the development process using ISPF 3270 in that wonderful world. Now, obviously, most of you guys probably don't like that process, right? I don't think that's what we're using in today's world. And what IBM came out with years and years ago was the CICS Explorer, which has a CICS perspective inside of it, right? So I'm switching over to the ZOS Explorer, right? The CICS Explorer, and showing you that I'm sitting on a perspective called ZOS. And in here, I could put in the same sort of qualifier. And you could see I could expand my list of COBOL programs. I could double click here for part prog. And you can see that it says location with an X. And I'm now going to change that location to a Y. And I'm going to save this change. Hope I'm going to save this change. There we go. Now I'm going to go off to the JCL over here. And I could run the integrated compiler, but just to be consistent, I'm going to right mouse click and run the non-integrated. I'm going to submit the job right from here. And you can see the job 2152 is submitted. I'm going to do a refresh over here so I can find my job. There it is. And I'm going to expand it down here. I could look at the JES message log, although I expected it to get 0 return codes. And then I could look at the same sysprint over here, right? And I could take a look. This was the compile that we looked at earlier. The only difference on this one was I changed location to a Y. Now, one of the advantages of using the CICS Explorer is the fact that I can switch perspectives to the CICS SM perspective. And now I can show you a little bit more about what my environment looks like. My environment is made up of a terminal owning region. There's a region called FUW-FWTR for terminal owning. Here are my 2 application owning regions. And I even have a file owning region where the file lives over here. So even though you might think CICS is relatively simplistic, my application, this tiny little program, runs across 3 different regions every time you run it. As a matter of fact, I don't even know which regions it'll go to. Here is me doing the same CEMT command, but now that I'm managing it across my entire CICSplex, I can actually see where this transaction ran. So far, what I can see based on the use count is that I actually kept running this transaction in this FWAR region. It has never been routed to this region. Problem is now that I've done a compile and a change, I can use the Explorer here, right mouse click, and I can do a new copy in both regions at the same time. And now that I've done a new copy in both regions at the same time, since this is a 3270 based application, I still will have to run it from a 3270. Keep in mind, if this was web-based, I would run it from a web. And you could see location with a Y. Now I'm going to run it just a bunch more times with no data, just to see if I can get it to run it in multiple regions. So now I'm going to go back to the Explorer here. I'm going to refresh this screen. And let's see, it's just not going to run in this region for me today. Don't know why, but it should. It could run in either one of these regions. It could be dynamically routed to either one. So these are two methods of development for a COBOL CICS program. The only thing you have to remember that's special here is that I was forced, of course, to do the new copy in order to bring in a new copy to CICS. And that's how we can control whether or not we've changed the program. Questions so far? No? Okay. So let's continue. Oh, go ahead.
I was just going to say it's been really quiet in terms of questions, but this is going great. Thank you, Ezriel.
You're welcome. So now I'm going to show you with pictures on a screen what we did, right? So here was the program, and I could take you through several more complex programs, but I will in just a bit. And what I'm going to show you here is we ran not the integrated translator. So there's a step before the COBOL compile that's translation. So obviously this is a picture of the integrated translator. So that's as part of the COBOL where that's okay. So again, the only difference is otherwise you'd have another step over there. Now, the compiler produced a listing. We got an object module, and then we did a link edit. And what you couldn't see necessarily was there's a CICS stub, right? A hexadecimal program that's inserted into your physical load module before it's loaded into CICS. And I'll explain what that was used for in just a second. But what you did to see, well, read command is commented out. It's replaced by DFH EI1 and a bunch of COBOL move instructions because that's valid COBOL. Now, this is how it works under the covers. So now that I mentioned the CICS stub, and I said that the CICS command was commented out, and you got a bunch of move instructions in a call, what do you think the call actually does? The call knows how to find the CICS stub. Now, this CICS stub is usually, in the current releases of CICS, hex 28 in length. So it's not a big program. And his whole job when running in CICS is to be able to find a CICS program known as DFH EIP. What is the EIP? EIP is the exec interface program, okay? Now, that exec interface program knows how to find the CICS component that will process the request for you. Okay, and so every time you issue a CICS command, it goes to EIP, he finds the component, it will process your request like reading a file, and then it will give you control back at the next sequential instruction. Now, the way you communicate with EIP is through a control block that I did show you that is inserted into your program known as the EIB. The exec interface block has certain fields that you can use to figure out what's going on. Like you could look at your EIB tran ID, so that tells you what transaction you're running under. You could look at your EIB cursor position to figure out where you left the cursor, right? More importantly, there's an EIB response code and a RESP2 value to figure out whether or not the command you just issued worked. Right? And we're also going to see EIB COM area length, which we're going to show you to figure out that this is not first time through processing. So Obviously, that was a simple program. Let's show you a more complex one, or at least the pseudo structure of a complex program. Remember, if we're running multiple tasks, then we need to restart a program where we left off. I mean, part was a really nice program, but what are we doing? We're running the same code over and over again. If we really wanted to step through a program and logically go from place to place to place, we have to know when is the first time through, and then when is the next time through, and when is the next time through. So here's an example in pseudocode. Remember I mentioned the EIB? When the EIB COM area length is 0, you're guaranteed to be the first time through, right? Because when you first start up, there's never any communication area because you as a programmer have to set one up. So you can always use if EIB CAN length equals 0, I know this is the first time through, add one to some data area that I have in working storage, do a send, and then instead of an exec CICS return, which is what I was issuing all the time, I'm going to do a return, identify the next transaction I want to run, which could be the same tran ID as this one, but pass it a COM area. And notice the COM area is coming out of task data. So if I added 1 to data 1 and it started with a value of 0, EIB CAN length is 0 the first time through. And this is the first time through logic. Now, if the user presses enter at the terminal where I issued this command, return tran ID with this COM area, the next time he gets started up, COM area length isn't 0 anymore, so he won't redo this code. And then notice I move the COM area from linkage to working storage because I'd rather work in working storage. But then I test if data 1 equal 1, which would be the second screen. So I could send the second screen after I've added 1 to data 1 and do a return. And then the third time through processing would take me here where you can see a full return, which means I don't plan to come back. And so now you've seen a pseudo application that would have typing in the tran ID, showing you the first and then the last screen and exiting. And I could show you an example of this. I just have some much more complex ones. So we mentioned COM area, and here is another use of COM area. When you actually want to invoke one program from another and you want to pass it some data, one of the other things you can use the communication area for is to pass data to a program that you're actually calling. So this is an example of me passing data to another program. Now, the problem with COM areas is they're limited to 32K. And prior to the most current release of CICS, which is CICS version 5.6, you actually couldn't use more than, I don't know, 32,500 bytes. You couldn't use the full 32,768, although they fixed that problem in the current release. The point is you get one area and it's 32K. Sounds very old school. So what IBM invented was something called channels and containers. A channel is a 16-character named area, and in it you can have named containers. So it's no longer via an address, very Java oriented. You refer to a channel and its containers only by its name, not by its address, right? Now, a container is an area that can contain an unlimited amount of data. Just keep in mind, CICS has some limitations. But you can have as many containers inside of a channel, and now when you invoke a program and pass it a channel, he can get multiple data areas in various different sizes for various different purposes. Now, again, if you actually do development in older systems, you're going to find more use of COM area than you will channel and containers, because channel and container, that interface is only about 10 years old. I know that sounds old, but it's really not in our world because our product is 50 years old, right? So that's actually a relatively new feature, but nonetheless, you might still find COM area in use all over the place, and that's why I mention it. So now let's talk about Zowe, CLI, and the CICS plugin, right? So I went down and I said, look, I can do it under ISPF. I can do this under the CICS Explorer with the CICS perspective. Let me try doing it under Zowe, right, using VS Code to do my development. And the first thing I learned was, even though I had, and I'll show you in the world of VS Code, I actually have the Zowe extension installed and even some of the other extensions associated with developing mainframe-based applications installed. What I didn't realize was I didn't have the Zowe CLI installed. Now, the way I figured this out was I opened a new terminal, I did no -- version, and it says, what the heck are you talking about? And so what I did was I went off to nodejs.org, went to download, and issued a npm command to install the Zowe CLI, and I gave you a link to the documentation so that if you want to, you can go there. Once I had the Zowe CLI installed, I also wanted to install the Zowe CICS CLI plugin information. Now, I did it from npm. I was told there is an official CICS site to download it from, and so you can choose either here or just issue this command, and it will download it for you. Now, to get any help in development under Zowe for CICS, you can issue the Zowe -- help from a VS Code terminal, and it will launch this inside of a browser, and it'll give you help for developing CICS applications using VS Code. But if you remember, developing a CICS application, as I'm going to show you in just a moment, is really about modifying COBOL code, right? There's only a little piece of it that you need to be able to do, and that is the new copy process, which I'm going to show you in a minute. So I had to build a CICS profile, right, so that I can actually attach to the backend system and issue commands. So this is an example of the profile I built. I built it for a CICSplex, even though it says -- region name. That is incorrect. It'll actually do an entire plex for you. Now, I'm just going to jump out of this. Sorry, trying to jump out of this. There we go. And what I'm going to do is, even before I go to VS Code, I'm going to go over here, open up a new tab, and put in the Zowe help. Actually, I'll just do it from here, right? So I could do Zowe, right? And that should pop open in a browser any minute now. And of course, when you try and do it, it's not. There we go, launching in a browser. And of course, in my world, it'll launch it in the wrong browser, so it doesn't work under Edge. So I'm going to just close it out of Edge here, and I'm going to switch over here. Sorry. Paste it in there. And you can see under the world of CICS, there's not a lot that you can do in the world of CICS, right? And I will tell you, add to list, define, right? Delete, right? These are all part of modifying the definition in what's called the CSD, the CICS system definition file. What we really need is to be able to get a resource and refresh a resource, which was the new copy I showed you earlier. So doing it in the world of Zowe is pretty much similar to what I showed you under the CICS Explorer. You go into your COBOL library, you pull up part program, and by the way, I should also show you what extensions I have installed. I have the Zowe Explorer, and I have the IBM Z Open Editor, right? So if you go back here for a minute, I like the coloration better here, and now I'm going to change location to a Z, right? And I'm going to save this. And you see I've saved it, and now I can go down here and I can go to my JCL library, right? And I can run this puppy, right? Submit the job, and it's submitted job 2212. And then I can look up my jobs down here, and it'll show me job 2212. And let me just minimize this so I can look at my job 2212. And you could see the Jazz message log over there, and I still got condition codes of 0. Yes, I know I'm not changing much in here. You could look at the COBOL compile again over here, as we mentioned earlier. But now we have an issue of bringing this into the world of CICS. Now, in order to do that, what I've kind of done is opened a terminal here, and I'm just going to issue this command that I have inside of here. And this is a command that will allow me to get the program in a nice fashion, I should say, from the regions where it's installed in. So I'm going to do a Control V. I'm going to issue this command, and it just says get resource, CICS program, the region name, and the plex I want it from. The name of the program is part program. And then I've put it together inside of a table, and I've asked it to tell me where it got it from. So you could still see the use count of 6, FW, FWAR, and A1, my 2 different regions, right? Now, my new copy across the entire plex looks like this Zowe command over here. Yeah. And I can copy this, and I can paste that in there, and it didn't work. So let's try that again. Control C, come on, let me copy it. There we go. Control V. And now I've done the new copy, right? And it'll come back and it'll say new copy successful. Yes. And now if we go back to our CICS environment, right? And we type in part 00001, you can see it says location with a Z. So the development can occur in any of these platforms, VS Code quite easily. You only need a couple of commands in this world to be able to do this. Now, special thank you to Alex, who showed me that you can actually build and run tasks inside VS Code. So this is an example where I can actually run a task to get the resource, right? And so you could see I could have set this up with some tasks, and it'll run those tasks for me. So if they're common commands, you can actually build and run tasks to be able to do this. Now, it really wasn't that complicated to build the tasks. Here's an example of the task itself, right? This is the one for get resource. This is the one for refresh program. And this is one that'll order the CICS actions in the right order. So it'll do one and then the other. And so if you want to, you can make your life easier. I would have liked to have had a prompt as to what was the program name. I just didn't get that far in development. But yes, it could easily be done so that you can build something nice. And hopefully they'll build a CICS extension over time that'll make things easier, right? So any questions so far?
There is one question, but I think we'll take that at the end. It's about, will we be talking about debug tools? So I think we'll hold off to the end. Okay, Ezriel?
Okay, yep. So this is just to give you an idea that CICS supports multi-region connectivity. You saw my environment has some route logic or a TOR. I had 2 separate AORs, and then I had a file-owning region, right? CICS invented this because in the old days, CICS regions were limited in size, 16 meg in the early days, 2 gig for a region size in the current days. And now we have stuff that goes above the bar, which provides for 16 hexabytes. So the reason for multi-region operation was twofold. One was redundancy in case you had a problem and a region came down. The other was physical space. So you're going to be able to see there's all kinds of CICS connectivity issues that are provided to support this environment. And this is just a screen that describes all those individual features from the page before. So I'm not going to go into the individual details. We wouldn't have time for that. I also want to mention that there is a whole system programming side to the world of CICS. I'm talking about application development, but there is a person's job who it is to maintain the environment, right? So he normally defines the programs, defines, excuse me, the transactions, defines the files that you have access to, make sure that the CICS region has access to those elements. And that's usually a systems programmer that will handle that for you. Now, I showed you a little bit about the master terminal command. That gives you the ability to do things like new copy, but you can use it for lots of other things, right? You can actually enable and disable programs. You can take a look, CEMT inquire task will tell you what's running in the system. And so a master terminal is also a friend of the application programmer to figure out what's going on in the environment. And I'm just showing you on the left-hand side, you can actually run it from the web as well. Now, access to CICS can be done in almost every different fashion as you can imagine. You can send XML, JSON. You can connect via TCP/IP 3270. A batch program can connect to CICS using EXCI. You can build user socket requests. A web browser can actually connect to CICS and so on. So CICS supports connectivity practically from anywhere, and CICS can connect outbound practically to anywhere. This is an example of an application that if I had time, I would demo for you, but it's simply me writing an application that uses CICS as a web server, right? CICS can send HTML, JavaScript, anything you want it to, and this is a Flash presentation, right? Martians watching CICS, right? I will show this for just a second, right? So if I pop this up, it's on a different site right now. I'll just show you that if I go to now, because I'm going to a CICS region, just like any other CICS region, if it does come up and it didn't come down, it'll ask me to actually sign on to the region. And if it'll get past this, there we go. And then what it'll do is it'll show you a Flash presentation being delivered. This entire screen is handled completely by CICS. There is no web server, and I can even go in here and run an application, right? And I, again, just removed the 3270 screens with HTML requests and responses with embedded JavaScript. And again, I don't know if this system is obviously acting slow right now, so you'll have to just trust me. Anyway, to finish this off, and before we get to questions, let me just say, CICS supports, of course, web services as a requester or a provider. So CICS is maintaining the environment for newer type things. So you can actually use Node.js in CICS today. I saw Spring Boot in the latest release. And so the developers of CICS themselves are trying to add all the new functionality that we know and like into the product to ensure that it's still being used moving forward, while you still have access to the COBOL applications from days of past or developing new COBOL applications. So I, for example, built some applications that go from Java to COBOL in a CICS region or from COBOL to Java inside of a CICS region. So no problem with that. I use a Liberty JVM for that. Now, I already showed you the CICS Explorer plugin, which can be used to manage or build applications within the world of CICS. So that's kind of what I wanted to show you today. CICS is ideal for existing transactional environments, and again, for new ones as well, because it does support the latest and greatest technology. And again, because of its availability and maintainability and scalability, it's a perfect development environment for your future development work. So now I'll open it up to any questions. And there is some further reading here I'll point out.
Awesome. Okay. So Ezriel, there is one question we'll start with. What is a typical way for a CICS application to provide user authentication? Does it provide LDAP directly or have to go through ACF?
So it wouldn't necessarily be ACF, right? Because it's ACF2, Top Secret, or RACF are the mainframe-based security, products. But when you log into CICS, you can actually set it up so that it can communicate with LDAP. Generally, you're not going to log in. That's more for a web service. So you can implement LDAP security with CICS. Generally, in the world of CICS, somebody has to eventually authenticate against one of the external security managers, right? So whether it be LDAP communicating with ACF2 or RACF or whatever it might be, to be able to figure out what authority you have in the CICS world, we still need to communicate with a back-end external security manager. But yes, you can still use LDAP.
Okay. I hope that answers your question, Alex. Thank you for the question. There is a question from Kevin. I'd like a quick clarification, Kevin, if you could help out. Your question is, will you discuss IBM debug tools and its various methods of being used? My question, I guess, is, are you asking about a separate session around debug tools, or here with the CICS interaction? If you could just say.
Well, while he's asking, I'm going to just show that CEDF, right, allows you to, you turn on CEDF and then you type in your transaction, and built into CICS, it'll stop you when a program starts up. Then it'll stop you before and after every CICS command that you execute. So you can actually see we're reading a record from a file, and this debugger will even allow you to change some data. Oh, if I can spell. Right? And so you could dynamically modify the data, and I didn't modify the right data. And then I've just changed the output message to hi everyone, and I can continue it in a pseudo-conversational fashion, right? So I can continue the debugger. This is built into CICS. You don't have to buy anything. The problem with this debugger is it'll only debug CICS commands, right? You didn't see the underlying COBOL. So usually to debug COBOL, people will purchase, debug tool or some other debugger from IBM or a vendor to debug the COBOL along with the CICS. But if all I were interested in is seeing how my CICS commands were running inside my COBOL programs, then I could simply run EDF as the debugger, right? Hopefully that answered Kevin's question.
Yes, it did. His response was either or, so that was great. Thank you for showcasing how that can be done in the CICS piece so.
Any other questions?
Yes, there's something here on our comments. I'm just trying to read it. I'm just going to read it out as it is. I'm reading it for the first time, Ezriel. So I'm currently working through the COBOL with Zowe tutorial with Open Mainframe, put out this spring. Is there a thought of having a follow-on CICS COBOL? Good question. Good question, Eric. We'll definitely take that input and keep you posted as we might know more on what would happen with that. In terms of, Paul, did you want to chime in here as well in terms of building out a CICS COBOL as an advanced course?
Yeah, it turns out that to set up in the COBOL, OMP COBOL environment, to let everybody use CICS, there's a lot of definitions that have to be done. So it's not something we can do quickly. We got to have a plan. So it's not something that will happen within the next couple of months, because we're going to do DB2 first. And while I'm at it, there is a question that was a good one from the YouTube channel, and I'll read it literally. What is the advantages of CICS having TOR, terminal owning region, and AOR application owning region? And before you answer, I'm going to mention that when I was in production, I used to worry if an AOR had a problem, other AORs could do the work. Ezriel talked about that. Also, I could scatter them across mainframes in case one mainframe went down. And there was a time many, many years ago when CICS did not have storage protection. And if one crashed, the others would just nicely take over. But anyway, I was going to let you answer that also.
Sure. So if you go back to the real early days when you had 16 meg regions because you only had 3 bytes to specify an address, if you figure out 8 bits in a byte and you only have a 3-byte address, what are you left with? 16 meg of storage to work with. Well, CICS became so popular, you couldn't fit all the stuff you wanted to inside of the CICS region. So what you needed to do was somehow split the regions up. And that's the real invention of a separate terminal owning region, a separate application, a separate file owning region. But then, as you'd mentioned, Paul, they realized that they could provide for additional redundancy and dynamic routing between regions right? If they just provided some new things within CICS to get it to work. And that's when CICSplex SM came out, right? So you can do dynamic routing between CICS regions. So originally it was an issue of space. Today it's more of a resiliency issue. However, I will say that now that we have access to the above the bar storage, so we're getting 64-bit addressing, although not yet in COBOL. Eventually, we can start collapsing some of these regions because there are some complications. There are customers I know of that have 2,400 regions. It's very hard to maintain and manage. As Paul mentioned, even building a class means that we have to have separate resource definitions for each student or have to have them dynamically allocated. So that's part of the issue. Now, I did notice one other question. One question might be, if you don't sprinkle the CICS commands throughout, will it still run? Yes, you can take a complete batch program and run it in the world of CICS. Now, why would you do that? Well, maybe you want to call a subroutine that does some batch function that you pass it some data and gets a response back. You can run that in CICS as well, so there's no problem. Yes, DB2 is good as well. So I'm looking at the messages now. Hi, better use of COBOL with GDSA memory. Yeah, well, once we can put COBOL above the bar, that will give us a lot of room. That is true. Let's see. Thank you. And then how hard is it to integrate multi-factor authentication for end user app, i.e. banking, based on CICS program for each transaction? If CICS uses LDAP, can it do something like Google Duo? I'm not familiar with Google Duo, but remember, multi-factor authentication is just prompting for another method of authentication to another device. So if you have a need, there's no reason why it shouldn't be able to do multi-factor authentication. And I will tell you, I have worked on multi-factor authentication processing in the world of CICS. Now, how it's done is very custom, or you buy a product. You know, I think Rocket has one that IBM promotes as MFA. So there are products out there that will allow you to do multi-factor authentication into CICS. But I'd need much more specific details, but the answer is yes.
Okay, and there is a question here in the questions section. Ezriel, we are CICS TS53. Can Liberty use JDBC type force to DB2? The follow-on question is, will you have a separate Liberty session?
I could. I've done it in the past. I will tell you the answer to your question is yes. I've used both, JDBC or CICS DB2 calls, right? One's a type 2, one's a type 4 connection to DB2. If you're already running Liberty in CICS, then I would assume that you'd want a type 2 connection and you wouldn't code JDBC call, because why would you do it? You might as well let CICS control the interface to DB2. Use CICS as a throttle for communicating with DB2. You can, however, if you want to, use JDBC. There's nothing that will restrict you because you're running in a Liberty JVM and you have access to JDBC. No problem whatsoever. I do have a presentation, by the way, I'll mention. It's getting Liberty running in CICS in under 60 minutes. And I like to always say, it takes me 60 minutes to present. It'll probably take you more than an hour to actually get it to run. But nonetheless, I do a COBOL link to Liberty, and I do a Liberty link to COBOL. And if you do want to hear more about that, just reach out to Sudarsana, and happy to put together a presentation for a COBOL Fridays.
Excellent. Thank you. Thank you, Ezriel. Anyway, on that debug tool question, there are a couple of follow-ons. And so turns out what Kevin was looking for was about IBM debug tool as it is under Rational Developer to show folks that environment. So
well, again, I stayed away. Notice I mentioned the CICS Explorer and the CICS Explorer. I didn't mention RDZ, which is now IDZ, because it's a 4-fee product. So somebody would have to buy IDZ. And then whether or not you have the debug tool, I don't know if you have to pay for it or not pay for it. But it's it's a line command debugger. It's like all the debuggers. You could step through a program, you could execute a bunch of stuff, Kevin, and look at a response, set breakpoints. So it works pretty much like all of them, but I'd have to build something to show it to you. I don't have anything running right now, but I do have IDZ, right? But again, it's a 4-feet product, so I kind of left it out of the presentation. I was more in the open source type thought pattern. Yeah,
absolutely, Ezriel. I think that was a great call there. That really is what we built that COBOL course on. So having that VS Code, Zowe Explorer, that was a good way to keep the connection with the course itself. Thank you for that. Thank you.
Yep.
I hope that answered your question, Kevin, but yeah. I think those were all the questions we had. And I'd like to also respond to a couple questions around the presentation and if there would be a replay link. All of our COBOL Friday sessions are recorded and available in our IBM Developer Hub page for COBOL. And this is the link to it. I'm posting it on chat, and I also did answer it in the questions section. So please do come back there, look for the replays, not just this session, all of our other previous 10 sessions we've had so far. There was a question about containers. I just pointed out that we've started a mainframe a la mode webinar session, which alternates every other Friday with COBOL Fridays. And last Friday was the first webinar on mainframe a la mode. And guess what? They covered containers and IBM Z. Is it a good fit? So if you really want to look into containers, definitely look at that replay. I shared the link under the questions section as well. And a quick thank you again, Ezriel, to you for spending your morning here with us today and sharing your expertise on CICS. It was really thorough, and everyone really enjoyed it. Thank you so much.
You're welcome.
Bye, everybody, and see you on Mainframe a la mode next Friday, and for our DB2 interaction with COBOL session 2 weeks from today on COBOL Friday. Bye, and have a wonderful rest of your Friday.
So long.